Okay, in this video we're going to derive an expression for the inverse hyperbolic secant function. And if we say the inverse hyperbolic secant of u, if that, say, is equal to y, then using the logarithmic form of the inverse hyperbolic secant function, we would say that y is equal to the natural log of 1 plus the square root of 1 minus u squared divided by u. So it looks like this problem here is going to be very similar to the previous integral when we're dealing with the inverse hyperbolic cosecant function. We want to find an expression for dx of this, which is the same as finding dy dx for this expression. So let's see how this works out. We have dy dx starting with our logarithmic differentiation. We're going to have this times the derivative of this. Growing up, we're going to have it multiplied by 1 over this first. And that will be the reciprocal of that. So we have u divided by 1 plus the square root of 1 minus u squared. Now we can take our derivatives. So we'll have this times the derivative of this expression. So we're going to have u times 1/2 times 1 minus u squared to the negative 1/2 power. And then we take the derivative of what's inside here. That will be minus 2 u du. Or rather u du dx, differentiating with respect to x. So that's this times the derivative of this. Then we're going to have minus this times this derivative. So that's going to be, for this part, is minus du dx minus the square root of 1 minus u squared du dx. And this whole thing is divided by u squared. So very, very similar to what we did in the previous video when we were dealing with the inverse hyperbolic cosecant function. Let's see. This and this cancel, and we'll take the u and put it over here. So this will be equal to 1 over u times 1 plus the square root 1 minus u squared. You take that out so you don't get confused now. And up here we're going to have those cancel, so we're going to have minus u squared divided by this square root 1 minus u squared. And we have a du dx, du dx, and du dx. We'll factor that out. So minus 1 minus the square root of 1 minus u squared times du dx. And again, we can write the minus 1 as minus square root 1 minus u squared divided by the square root 1 minus u squared. And let's see, that will be equal to, this stays the same of course, so this is u times 1 plus square root of 1 minus u squared And here we're going to have minus u squared minus the square root of 1 minus u squared divided by square root of 1 minus u squared. And we have this term times du dx. So again, just as in the previous video, we're just kind of going through the algebra here. The algebra is very similar, almost identical. Let's see, so this is equal to 1 over u times 1 plus square root 1 minus u squared times, and now we're going to have this minus this, so we have minus u squared minus the square root of 1 minus u squared. Then square root sign goes away, so we have minus 1 minus u squared divided by the square root quantity. Times du dx. Okay, now it looks like here we have minus u squared plus u squared. So this and this are going to cancel. And then we're going to have minus this minus 1. Take the minus sign out there, and we're going to have this plus 1. So we have 1 plus this, and that's what we have down here. So those are going to cancel. So this is going to come out to be equal to 1 over u times the square root of 1 minus u squared du dx, and there's a minus sign here. And that is dy dx. But dy dx is the same thing as this with respect to x. So this is equal to d dx of the inverse hyperbolic secant of u. And so there it is. It's kind of a weird expression, but that's how it turns out. And again, the only calculus part was up here when we had to do our logarithmic differentiation, and after that it was just kind of going through the algebra. And also remember that we use the logarithmic form of the inverse hyperbolic secant. Took the derivative of that, which is the same thing as doing this, so that once you found dy dx, it was also this expression here, which is how we're going to get that down here. So that's it. Nothing more to it than that. Come back and join us for some more videos, and we'll see if we can work through some more problems.